It's a topic where you can enjoy for long time. Okay. So even if I teach today, I might take 2 sessions. Mm, Is this visible? Is this visible?
Uh, yes, sir.
Huh. So you have niobium and ruthenium containing X and Y number of electron in their 4d orbital. Then what is the XY value? Now, if you are reading for very first time and you don't know anything, because I am assuming it, then first we should know what are the d block element. What is the relation of the d block element with the transition element? And if you know, then what are the different series 3D, 4D, 5D, and 6D? You have total 4 series. Okay, 3D series will have 10 element. Then 4D series will have second 10 element. Correct? This is related to 4D series. It means it will belong to the second row. Then you should know what is the sequence of this 10 element. So it means understanding every element is really important. So that's why for this it's good we can start from the scratch. But I will not. What should I say? I'll cover whatever is required for the NCRT. D block from group 3 to 12. How many period are there? 4. Which one? 3D, 4D, 5D, and 6D. Okay. This is about the D block. You know, we have 4 blocks: S, P, D, and F. What is the criteria? Last electron enter in which subshell? We recently did atomic structure, Sara, right?
Yes, sir.
And there we did this part. There are 4 subcells: S, P, D, and F. Based on the number of electrons present in each subshell, there is a number of groups. Example: S have how many electrons, Sara?
Sir,
2.
2 electrons.
Samarth? P.
6 electrons.
Sara? D.
10.
Then and uh, Samarth
14,
F.
sir.
14. Based on the number of electrons, same number of the group will be there. Okay, same number of group will be there. Example: S block have 2 group: alkali metal and alkaline earth metal. P have 6 group, group 13 to 18. D have 10 group and F have 14 group. Right? There is a long row of the 14 group. Right? Any doubt? See, that's why here this D block start from the 3 to 12. Okay, it start from 3 and with the 12 because 13 to 18 is Samarth. What is 13 to 18? D block. Sara, what is 1 to 2?
Sir, S.
Uh, S block. So 1 to 2 S, 13 to 18 P. So in between D block. Because it is present between S and P, that's why it is known as transition in between, right? Transition in between. Any doubt? Same way, you have F block, 4F and 5F. 4F is lanthanoid, 5F is actinoid. And D block is known as transition metal. Why? Because it lie between S and P. And inner transition metal means F. We are talking about F. Why it is known as inner transition element? It is present within D block element. Okay, transition element. That's why inner transition element. How many series are there? 4. 3D, 4D, 5D and 6D series. Okay. Same two series in actinoid, lanthanoid series and actinoid series. Right. This is known as lanthanoid series and actinoid. Okay. What is the definition of the D block element? Any element in which last electron enter into D subshell, this will be known as D block. Samarth, what is the difference between D block element and transition element?
Sir,
Samarth,
aren't they same?
no, no, they are not same. See, when we are saying ki D block element means last electron enter into D subshell. When we say transition element, its simplest meaning is ki a element that have incomplete D subshell, incomplete D subshell, whether in normal condition or common oxidation state. Normal means ground state or common oxidation state. Understood? Any doubt?
No, sir.
No, sir.
Example. These three are extremely important. Zinc, cadmium, and mercury belong to group 12. So they have full D subshell, full, both in ground state as well as common oxidation state. That's why these three elements are D block element, but not transition element. Understood? Why? Example, if you take uh, any manganese atomic number is 25. So 3d5, 4s2. Here D subshell is incomplete, right? If you take copper 29, it is 3d10, 4s2, 1. Correct. Even in this situation, ah, ah, ah. So uh, here D subshell is complete. Sarah, is it the transition element or not?
Uh, full- Sir, it has complete D subshell, so it is transition element.
It is not transition element because D is subshell, right? What we said, ki there should be incomplete D subshell. Here it is complete. D is full. Correct. It is not a transition element, right?
Yes, sir.
Yes, sir.
Answer is no. That is the special thing. That's why I took copper example and NCRT also took copper example. Ki logically you will see ki oh D is full, so it is not transition element. But according to definition, it said whether in the ground state. In ground state, it is not transition element. But if you take common oxidation state of copper is copper 2 positive, right? 3d9. Now tell me, is it transition element? Yes or no, guys?
Yes, sir.
Yes,
It is
sir.
transition element. Okay. So in 3d10 state is ground state. It is not transition element in ground state. But in common oxidation state, it is. So it will be considered as कि this is a transition element ultimately. But if you take zinc have 3d10 4s2. Common oxidation state is zinc 2 positive, still 3d10. Is it incomplete D subshell in both common oxidation state or ground state?
No, sir.
So can we say this is not transition element?
Yes.
Makes sense? Any doubt?
No, sir. Understood.
No doubt.
Very important, and especially in board, it is very popular question because for NEET JEE, it become too easy, too obvious. But now I got both of your idea. You need to work, especially in case of DNF block. Correct? Look at this definition now. Extremely important. Key. According to the IUPSC, अरे, according to the IUPSC, transition element. What are the transition element? Transition element are defined as metal that have incomplete d subshell either in the neutral atom or in its ion. Understood? Or any common oxidation state. When I said ion, common ion, any ion. Understood? So zinc is ion, still it is complete. In ground state, it is complete. So you will say in both the situation, it is not a transition element. Any doubt, guys?
Sir,
Hmm.
in some oxidation state of D0 and 4s0 also.
No, then D, you have to see कि does it belong to the D block. If it is D block, example, if you take uh,
The chromium plus phosphate.
example scandium.
Yeah,
Scandium is 3D1 4s2, right?
yeah.
Because atomic number 21, organ 18, and remaining 3. But if you take scandium 3 positive, very common oxidation state, it will be 3D0. So this scandium is fulfilling first criteria. In ground state, it is transition element, right?
Yes, sir.
In any of the situation, whether ground state or common oxidation state or any ion, if it contain incomplete d orbital, you will call it as transition element. Anyone.
Okay, okay.
Understood?
Yeah.
Yeah. So when it come to the d and f orbital in the formation transition element, it is different from the non-transition element. Many property are different. That's why we have different septum. Correct? But basic thing are applied everywhere. That is theory of valency, like how you calculate valency, how you lose electron. This method is exactly same. Okay. It was not important, but I am just telling you. D block element lie between S and P. Very basic thing. How to do this electronic configuration is important. N minus 1D, N S 1 to 2. Sarah, is N minus 1D? What is the name of this shell? Sarah, what is the name of N minus 1 cell? Sarah, are you there?
So,
Yeah. See, if you take last shell, N, then it is known as ultimate cell. Yesterday we did this. N is known as ultimate cell or last cell. Ultimate or last cell or limiting. If you take just before that, it is known as penultimate. Just before the ultimate. So in this chapter, you will study the electron of D subshell enter into penultimate cell. Penultimate means before the last cell. N is ultimate. One before that is penultimate. Any doubt? because D can have maximum 10 electron. So D electron here could be 1 to 10 anything. And in case of this S, you will see it could be 1 to 2. Why? Because usually you will see S will have 2 electron in this situation. Usually S have 2 electron. But special case example in case of chromium and copper, right? You know this chromium 24. This is 29. Logically, it should be 3d4, 4s2, 3d4, 4s2. But because you know half field is more stable, what actually you do in this situation? You write 3d5, 4s1. Correct? Same here. 3d10, 4s1. So s could be 1 or 2. Yes or no, guys? Any doubt? And why we are writing n minus 1d? Example, if you take 4s, uh, Samarth, what should be d value? Value before d.
Sir, 4S, like?
3d.
Hmm.
Because if
Okay, okay.
before s
3.
and value is 4, then it will be 1. Sarah, if you take 5s, what will be the d value? Sarah, if you have 5f, before that, what will be d value?
So 4D,
4d. Samarth, if it is 6s, what will be d value?
5D. 5D,
And
4F.
if it is, yes, if it is 7s, uh, Sarah, what will be d value?
6D.
6d. What will be f value? F value you will see n minus 2. So what should be the value of f in this case?
4F.
Samarth, yes, 4f, correct. Samarth, what will be the value in the above value? 6s2, 5d10, what should be the f value?
So 3F?
No, 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 wait.
No, no, no.
3f is
3F.
not possible. It will
3F is
be
not possible.
5. It will be 5f.
Sir, 4F was for above 1, right?
Yes. What I did, if you are taking this n, this is n minus 1, this is n minus 2. Understood? Same here. If it is n minus 1, this is n minus 2. Any doubt? Any doubt, guys?
No,
No,
sir.
sir.
Do you guys have uh, specific this mnemonic for all this, like you have learned in your classes?
Sir, I just remember the elements.
If you can remember, it's good, but in long run, you will always forget.
Sir, it was there in coordination also, sir.
Yeah, so like comparatively, it is easy, but you should have some mnemonic. If you have early mnemonic, I will not tell mine because mine is not so great. It worked for me. Remember, your mnemonic always work for you, whatever it is. Even you feel ki it's not so great, but working for you, that's what you need, right? Example, what I made this was not so great. Sakti Vakar में फैंको निकुंजन. So it is like particular Hindi term, but let's see from Chat GPT if we can get good mnemonic, good, funny mnemonic for 3D element series. School teacher very cruel, make friends cry near canteen zone. Wow, see which one you would like to add? Like I'll add that part. School teacher very cruel, make friends cry
Yeah, so the
near
first
can
one is easier to remember.
school Sakti. So you can choose anyone. I will not do. Reason because whatever I have, it is working for me, right? So even you can make your own. But if you feel remember, make sure it is relatable to the element. It should not be like you forget which element is related to this. Okay, which one you want to use, you can add in your notes. And remember, you have to send me notes after this class. So keep making notes. Don't forget this. Okay, you have to send me notes after this class because this chapter notes you actually need. Because I read Sakti Vakar Me. Why? Because when I say Sak, S-C, Sakti, Va, Kar, Me, Fanko, like throw, Fanko, Ni Kunjan. So, what I'm able to do is ki, it is related with all the element written here. If you don't have any, try to make by yourself. If you can't make, tomorrow I'll uh, tell you. Okay, I'll make something funny in proper English, and but this is not so great from my side. What I feel. So, first element is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. You already know what usually happen if you see so, scandium configuration. Scandium atomic number is 21. Organ have uh, noble gas configuration. So 3D1, 4s2. Easiest way is whatever is the number, same will be the D subshell electron, except few special case. Understood? 21, 1, 22, 3D2, 23, 3D3, 24, 3D4, 25, 3D5, like this, except these two chromium and copper. Understood?
Yeah, sir.
So, uh,
Yes, sir.
uh, so what we can see here is electronic configuration become easy, and because you mentioned key you have in coordination compound also, it's easy to correlate. But you can't forget for chromium and copper. Very special case. Why? Because in case of chromium, it should be 3D44S2. Actually, it is like this. But there is a change. And what is the reason for the change, Samarth?
Stability of half bits.
Half-filled orbital are highly stable. That's why one uh, electron move from S to D, and now all the D orbital have one electron, even S have one electron, very stable. Like it's like if you are giving bread to beggars, and everybody will have full stomach in two bread, but and there are total five beggar. You give bread to four beggar, and you leave fifth one. What will happen? They will fight with each other, and nobody will have stability, right? Nobody will eat properly. But if you take from one bag, like if to all six the beggar, you give one bread, it will be perfect, stable. Everybody will have at least one, if not two. Make sense?
Yes,
Make sense?
Yes, sir.
And what are these six beggar I'm talking about? Five beggar from the D orbital and one orbital from the S. Total six beggar. So you distribute one bread to each and every person, so they are stable. At least they are eating something. Everybody is eating something. You don't want to leave anyone because you will feel bad. By the way, from the bread, Sarah, Christmas cake, ಮಾಡಬೇಕು.
Yes.
ನಾನು देखा like I need your Christmas cake. How you are going to send?
Uh,
Nowadays we have delivery. You can like
yes.
courier, super fast delivery, right? Like within 1 day.
Yes. Yes. Yes.
Because I heard like in your family it's very popular. You celebrate together.
Yes, sir. Jordan is at my home now. I mean, in Ramnagar.
Is he in your home?
Yes, sir.
Okay, but you are not in your home.
Yes, sir.
Oh, wow. Okay, so half is more stable. Sarah, tell me. And this copper. Copper should be logically 3D9 for S2, right?
Yes, sir.
But what is the reason why it is 3D10 for S2?
Uh-huh. So the energy gap.
Because full filled will be highly stable.
Mhm.
Here half filled is more stable. Here example, uh, if you see 9, again there will be fight between the people. But if this as person give one bread to this, at least 5 people will be happy, right? So more people are happy when you distribute equally. Correct? Any doubt?
Yes, sir.
No, sir.
So these are the reason and very popular question they are. Same thing they tell कि in case of chromium it is this and why? Because energy gap between 3D and 4S is very small. Correct? So uh, because of this energy gap, electron can easily move from the S to D. Correct? Any doubt? Now, this is the second series. I made this trick. Do you have any trick for this?
No,
Do you
sir.
have Samarth?
Sir, Ratta.
Ratta? Do you understand Hindi, Samarth,
Yeah,
properly?
sir. बहुत अच्छे से.
Sarah? बाप रे बाप. Sarah, like you understand Hindi properly?
Yes, sir.
Huh. So, I made this trick almost like 12 years back. Yaar,
Sir.
uh, Sarah, I think you have network issue. यार जरा नजर मोड़ तेरी रूस रही पड़ोसन आजा चंडीगढ़ आजा चंडीगढ़ चंडीगढ़ is one of the popular city in and shared capital between Haryana and Punjab and Union Territory as well, right? So it's like couple is upset with each other. They are not talking to each other, and then you are making this कि यार जरा नजर मोड़ तेरी रू यार जरा नजर मोड़ तेरी रूस रही पड़ोसन neighbor come to Chandigarh and convince her. Maybe that sort thing. So why it is important? Because here you have niobium in your question and you have ruthenium in your question, right? The exact question we have here, niobium and ruthenium have x and y number of electron in 4D orbital. So you should know what is the number of electron in the 4D orbital. How to know? Niobium and ruthenium, na? See, niobium have 41 electronic uh, atomic number, correct? So This and ruthenium have 47 5s2. So what is the total number of electron? What is the total number of electron in neobium in 4D? 4. What is the total number of electron in Am I audible, guys?
Yes, sir.
Yeah, sir.
So, what is the number of electron in ruthenium? 7. What is the number of electron in niobium? 4. What is the total number? Chat. Hmm. What is the total number of electron? 11.
11, 11.
If you know this chapter, do you think that this question was too easy to solve?
Yes, sir.
But again, you need to revise this. Make sense? Understood?
Yes. Yes, sir.
Sarah?
Yes, sir. But could you explain that again, sir? The 4 and 7.
Yeah, sure. This is what required. Even I showed you that it is given in NCRT, ditto NCRT line. But here you don't have regular pattern. What you need to understand, in first two it is normal. Okay, in first two it is normal because 36 is Xenon. Xenon is 36. Okay, and Xenon is 36. After that, what is the number of yttrium? 39 means 3 electron extra. So it will be like for yttrium, Xenon, 4, 4D1, 5s2. Understood?
Yes.
Yes, sir.
Same way. Here 4D2, 4s2. But the problem is here you have so many exceptions. Continuously 5. Why? Because of the energy gap is less, so lot of electron can enter into d orbital. And why they are entering? Because everybody in d orbital want to stable first. Correct?
Yeah.
D orbital, because 5 people are staying together, they want to stable themselves first compared to the uh, 5s. Correct? Any doubt? Then you will ask, sir, why this palladium? Because again, full filled orbital are more stable compared to the incomplete orbital. Here you have full filled, here you have full filled, here you have full filled. Okay. Why not in the 3D then? Because in 3D, still there is enough gap. So it can prevent unlimited number of electron to move to the 3D. Example, look at this. This is what given in the NCRT also. If you look at this, I will write. If you look at this, I will mark this part again and read NCRT what is given. Consider chromium. This electronic configuration. This why energy gap between two sets 3D and 4s is small enough to prevent electron entering into a 3D orbital. Still, there is enough gap, but here energy gap is less. Here energy gap is less, so electron can easily move. In case of 4D, that's why you will see in last three element only one concept is applied: full-filled d orbital. Okay, full-filled d orbital. Understood?
Yeah, sir.
Any doubt, guys?
No,
No.
sir.
Then again, you will ask, "Ki, sir, up to this, it was still fine. Ki we were trying to cope up. In next round, again, there is no exception in first seven element. And then suddenly, here, it is not again like 6s2 and like 6s0 and 5d10. It's not like that, like above one. Reason is here you had lanthanoid in between after lanthanum. Understood? Because after this you had so many in between element and they made impact. Lanthanoid made impact. Understood? Lanthanoids made impact in this situation. Those 14 lanthanoid. And because of that, size is small. Size is small means energy gap is big. Energy gap is big, electron will not easily move. Correct? But you will see this thing is common. If you compare overall, then one thing is common in every situation. At least you can correlate with it. This one. Whether you take copper or silver or gold or rontagium, rontagium. So in all the uh, situation, what is happening? Second last element, group 11 element, try to complete its fulfilled d orbital. Yes or no, guys? And
Yes,
Samarth,
sir.
because 4D have so many exceptions, that's why even J people know you will make mistake in the 4D orbital.
Yeah, sir. Yeah.
ಅರ್ಥ ಆಯ್ತಾ?
ಆಯ್ತು ಸರ್.
Hmm, sorry. So this is the thing. Again, they wrote the same stuff. See, because same stuff, ditto same. Zinc, cadmium, mercury, copper, all these are the group 12 element. Remember, group 12 element are fulfilled. Group 11 always 3d10. Sorry, not 3d10, d10. Okay, these group 11 element have d10 because they try to complete full filled orbital. Okay, and here because their d subshell is fully filled, and even in ionic form they don't have incomplete d orbital. That's the reason why they are not regarded as transition element. Same thing they wrote again. Any doubt?
No, sir.
Huh. Sarah?
No doubt, sir.
Huh. D orbital usually come out of their shape. Like usually it should be like this, spherical, but it came out like this. Okay. So they protrude periphery of the atom more than the other orbital, like S or P. And because of that, they are more influenced by the surrounding. Example, when you read about the coordination compounds, when you read about the coordination compound, then you feel it. Ki ligand are easily influencing the orbital, right? Yes or no? This is what you need to work on. Ki how you correlate multiple chapters. When you are doing this crystal field theory, you know central atom orbital will split in presence of strong or weak ligand. And based on that, there are different behavior. Mm, Tell me, both of you, like, do you correlate as of now in chemistry ki how different chapter are linked with each other?
Yes, sir.
Someone, you do this?
Yeah, from chemical bonding it starts.
We did chemical bonding, na, like that. Like how we correlate.
Yeah.
Huh. Sarah, do you do this like you correlate multiple chapter together? Sarah,
No,
Anthony, am I audible?
yeah, sir. I
Huh.
don't, sir. Not much.
Not much. And remember, when you are not doing, na, it's not your mistake. Your teacher is not teaching you ki how to correlate multiple things, right?
Yes, sir.
So, this is what happened. Like, Samarth, like you never had this experience in your Diksha, like they correlate every chapter, every topic with the other topic.
Sir, one teacher did, sir, other teacher did. Like there were two tracks.
Okay, there are two tracks. So one teacher really correlate with other.
Yeah, in this thing, coordination compounds, they explained why in tetrahedral complexes the splitting is different. So,
Hmm.
yeah, like the d orbital, one of them is like extremely outward protruding. So in case of tetrahedral,
Hmm.
higher energy, uh, like, I don't know how to say.
It's okay, but that's good. Like, they did well. We
Yeah,
appreciate the
but
first teacher.
in this chapters it's not.
So, this chapter is actually feel really boring for many people. That's the thing. You like solution, you like chemical kinetic, you like electrochemistry. You also like coordination compound. When it comes to the DNA block, now you feel like this and biomolecule look boring. Am I right,
Yeah, sir.
Sarah?
Sir, I like biomolecules, the protein part only.
Because you have in biology, at least you can
Yeah, sir.
correlate. These students feel really boring in biomolecule. It's like why we are reading biology when we left it already.
Yes.
Okay, so guys, move to the next. D orbital, because they protrude out. Because of that, they are like easily influenced by the surrounding. And when you correlate with the surrounding, crystal field theory, ligand can influence them. Okay, this thing, remaining thing will study throughout the chapter. The best property about the D block element is they have multiple oxidation state. Chromium can have +3, +6, very two famous. Manganese can have +2, +4, +6, +7. Iron have +2, +3. Copper have +1, +2. So they have variety of oxidation state that is very unique. If you see in S and P block, usually they have limited oxidation state. You will see group 1 element, sodium, potassium, lithium, they all have only +1, right? Right? Aluminium is usually have +3 only, right? But here they have variety. This is a unique thing. Remember, whenever you are reading in chemistry, focus on the what is the unique thing about the element. These are the colored substance. Why colored? Again, variable oxidation state, and because there is an incomplete d orbital. If there is no electron in the d orbital or full electron in the d orbital, both are colorless. That's why you will see zinc and scandium 3 positive, zinc 2 positive and scandium 3 positive. Both are colorless. Why? Because there is no unpaired electron. In D, all are full, and in scandium, there is nothing. Make sense, guys? And same
Yes.
thing is given again in the coordination compound in crystal field theory. Ki why there are different color of the compound. It is mentioned ki why if you take copper sulfate and hydrous, it is colorless. Right? But there is more importance of the ligand. Ki ligand make impact. Ligand make impact, right? Ligand make impact. Here it is ki if there is all paired electron or no electron at all, colorless. That's why you will see ki, you will see one factor physical property. You are not supposed to remember any color of the substance, oxidation state. See, one of the notable feature of the transition element that great diversity in the oxidation state. Notable feature. Example, except scandium and zinc, most of element have more than one oxidation state, right? Why on the extreme level there is only one oxidation state? Answer is more stable because they have limited number of electrons. Example here D have only one electron. It donate, become colorless. Here zinc is stable only in two positive because D is already fulfilled. Makes sense, guys?
Yes, sir.
Yes or no?
Yes.
Yeah.
And element have maximum oxidation state in the middle. You know, manganese have maximum +7 in the middle. 7 chromium have +6. In the middle, you have the maximum oxidation state. Why? Because maximum number of unpaired electron. Example here, it is 3d5 4s2. All five are unpaired. This can also become unpaired after excitation. Same here, 3d5 4s1. All six are unpaired. So that's why you can see here maximum +6. Here maximum +7. Makes sense? Number of unpaired electrons. On the extreme end, it is less. Why? Because electrons are not available or all are paired. Okay. Now you can see variability of oxidation state is the characteristic of the transition element because it does not happen in other. Okay. Here you will see in p block element, lower oxidation state are favored by the heavier member inert pair effect. Still, you will not understand this point. Sarah, tell me, did you understand this point? P block element, lower oxidation state favored by heavier member due to inert pair effect.
No, sir.
Sarah. So let me tell you what happened. If you see group 13, group 13 like bangan, aloo, gajar in thali. So in group 13, you will see higher member have usually +3 charge, but you will see thallium have only +1. Heavy member have less charge. Okay. Same in group 14, carbon family, Kartikeya, Shivji, Ganesh, Sang, Parvati. If you see, first member have +4, but lead show +2. Okay. Same in 15th group, nitrogen, phosphorus, nanoparticle, Aishwarya, Sabindas. So if you see, heavy member can show +5, but it show +3. So what is happening in every situation? Your l- heavy element have less oxidation state. Heavy element have less oxidation state. Why? Because 2s electron do not participate in the bonding. And the reason is inert pair effect. As the name suggests, inert means not active. Inert means not active. One pair is not active for the bonding. So if one pair is not active for the bonding, so one pair will be less. means two electron will be less. That's why higher member three, here only one. 3 to 1, 2 reduction. 4 to 2, 2 reduction. 5 to 3, 2 reduction. Now tell me both of you, any doubt, Sarah?
No, sir.
Understood what is inert pair effect?
Yes, sir.
Samarth, was it easy to understand?
Yeah, sir.
Inert pair effect means one pair of electron is inert, not active for the bonding, for oxidation state. Okay. But in case of D block element, it is opposite. How? Heavier element will show higher oxidation state. Example, if you see chromium with the +6 oxidation state is not so stable, but element present below the chromium. Okay, so it is 1, 2, 3, 4. Molybdenum, tungsten, seaborgium, all these elements, what I just encircled. This molybdenum and tungsten are highly stable with +6. So what is happening in this situation? If you are going down from chromium to molybdenum and tungsten, here higher oxidation state becomes becoming stable. Here +6 is not so stable. Here it is. But if you compare with the boron with thallium, carbon with lead, nitrogen with bismuth, here it is reducing 3 to 1, 4 to 2, 5 to 3. Here it is reducing in P block. But in D block, it is ulta. Understood? Make sense, guys?
Yes.
Any doubts? Yeah. So this is the thing, and that's why chromium, it is showing key. Chromium is a very good oxidizing agent. Why? Because it easily convert into lower oxidation state. Why? Because 6 is not stable. That's why it is converting into other. Makes sense. If chromium is not uh, like chromium don't like +6, what it will try to do? It will try to go in the lower state, +3. So very good oxidizing agent. But molybdenum or tungsten are not oxidizing agent. Why? They are happy with +6. They are like, no, we don't want to go anywhere else. We are happy with that. Makes sense. Okay. There are some elements that can form lower oxidation state, as you can see here. Both nickel and iron or even manganese can show zero oxidation state here. Reason, strong ligand will make it stable. Samar, do you remember what we did in the coordination compound? Ki nickel is 28, 3D8 4s2. What cobalt will do? Cobalt is a very, no, sorry, not cobalt. Carbonyl is a very strong ligand, extremely strong ligand. What it will do? Cause pairing and it will make 3D10. Tell me, is it really
Yes.
stable? Exactly.
Yeah. Yeah.
Very stable. Very, very, very stable. See, transition element that do not show variable oxidation states, scandium and zinc both. I will write one more. One is scandium, second will be zinc. Okay, scandium and zinc. Why 3D series of the transition element exhibit large number of oxidation state? Because electron can easily move from the S subshell to D subshell. Correct? 3D 4s. Electron can move from here to here, so that's why it is possible. Understood? Now we were talking about the color, chemical reactivity, magnetic property, formation of color. Samarth, what I said about color?
The unpaired electron should be there in D
Yes.
block. And
I said ki if
right.
d orbital is vacant or d orbital is full, these are colorless. Otherwise, in any incomplete d orbital, it will be colored. Understood? Any other thing will be colored. Any doubt, Samarth,
No, sir.
Sarah?
No, sir.
No, no need to read anything else. See, if you see scandium 3 positive and titanium 4 positive is colorless. Why? Because no electron in D. All are other are colored, we don't care. Okay? All other are colored, we don't care. If you see again zinc become colorless, why? Fulfilled. So either empty or fulfilled are colorless. All other are colored done. Either it should be empty or it should be full. Both are colorless. Was it easy to understand? So that's why you need to approach every chapter with the different way. Ki when we were reading another chapter, we never did any other chapter like this, right? But here we are supposed to do. Because if you read in sequence, you will close your book within 10 minutes in this chapter. Okay. Then they form complex. We did this coordination compound. They form complex with ligand, right? We did. They can act as a catalyst region, variable oxidation state. I'm very, 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 very hungry. Sarah, you had your dinner.
No, sir.
Samarth, you had your dinner.
No, sir.
I'm very hungry. I'll just finish this one, two line, then I'll have because Sarah, you will have test, right?
Yes, sir.
Test is ready, so have your dinner and then we'll finish this. Okay, catalytic. Why it act as a catalyst? Because variable oxidation state. And many have paramagnetic behavior. Why? Incomplete d orbital. Okay. Example: this whatever is the colorless will be dimagnetic usually. Zinc is dimagnetic. Scandium is dimagnetic. Why? Electron are paired. Understood? Any doubt, guys?
No, sir.
So could you
Last
repeat?
question. I said most of the D block element are paramagnetic because they have incomplete D subshell. Because they have incomplete D subshell. If it is complete, like in this situation, zinc or scandium 3 positive, both will be diamagnetic. Why? Because they have fulfilled d orbital or incomplete. So all electrons are paired. The simplest criteria of dimagnetic and paramagnetic. Paramagnetic means unpaired electron, and dimagnetic means all electrons are paired. Understood, Sarah?
Yes, I understood.
Yeah. Why scandium is transition element? Because incomplete d subshell. Why zinc is not complete d subshell? Then, guys,
Yes,
if
sir.
you under if you understood this, majority of the property are done because basic is done. You will face difficulty in ionization enthalpy that we need to do, but majority of the thing, basic part is done. I wanted to solve more question, but due to the hunger issue, see K2CR207, direct formation, first step, K2CR207, first step. Do we have any other property? Magnetic, again paramagnetic, dimagnetic, lanthanoid contraction. Lanthanoid contraction is really important for you. See, which correct set of iron with the same color. Now you can see that these three will be colorless. How do I know? Zinc is fulfilled, scandium is zero, titanium is zero. Yes or no, guys?
Yes,
Because
sir.
here it will be 3D0, 3D0, 3D10. See, same question. You don't care about which color. It just keep whether it is colored or colorless. Understood?
Yeah.
Straightforward question. Send me your notes, and then in next class I'll first do three topic. K2CR207, KMNO4, lanthanoid contraction. Then we'll start question. Okay. If I get time, I'll tell you. I might take one more class today if I get time, and I'll do directly K2CR207, KMNO4, and lanthanoid contraction first. अर्थ आया था?
Yes,
Yeah, sir.
sir.
Tell me, guys, Samarth, is it difficult to solve this chapter question?
No, sir. Concept based are nice. Memory based are difficult.
Yes. Sarah, is it difficult?
No, sir.
Okay. Then see you guys. Good night.
Thank you, sir.
Send me
When do
Thank
we
notes,
re
both of you. Yes, Samarth.
Sir, when do we rejoin, sir?